All right, guys, going to do an example of changing a parabola to standard form here and graphing one more time. I'm actually going to do example number 3 because our numbers are a little, I don't know, not so friendly on this one. And we'll have to complete the square one more time. So first thing I'm noticing about number 3 is it is a y-squared parabola to start off. And we'll have to complete the square. So I usually do that the same way. I'm going to get the y's all together and factor out that coefficient. So I'll have 1/2 that 0.5 y squared minus 6y. Up to you if you want to move this over. I usually do equals x minus 11.5. All right, and then completing the square. So I take our middle term divided by 2, which is 3, and square it. So I get a 9 in here. Since I added a 9 on this side, you can subtract it. I'm going to do this a little different for my last example. On this left side, since I really added 9, but we really added 1/2 of 9, I have to do the same thing on the right side. All right, and then we factor. So this will be 1/2 y minus 3 squared. And this guy is going to be, this will be a 23 over 2 plus 4.5 negative 7. Hopefully, I think I'm good. All right, and that will be how we complete the square. Then for our final standard form, usually we just put that coefficient on the side that is not squared. So I'll have 2x minus 7. So here's the standard form of our parabola, and we can get a number of things from this. So we'll have the vertex, which will be at 7, 3. We know that 4p equals 2, so p is going to be 1/2. And I'm going to start graphing this with that information. It's going to be a pretty small parabola here. So my vertex is going to be at 7, 1, 2, 3. And since this is a y-squared parabola, we know it opens horizontally, so either right or left. Since this is positive, it's going to open to the right. So this means from the vertex, go 1/2 to the right, a vertex to graph our focus. So from the vertex, I'm going 1/2 unit to the right, putting it right there. That would be my focus. So I'm just going to write it in. It's really hard to see on our graph. The focus would be 7.53. Okay, now a nice kind of quick, easy way to graph would be using twice the distance. And the reason this is, again, I'm going to draw in our directrix here, and I go the other way. So I went 1/2 unit to the right for the focus. For the directrix, I go 1/2 unit to the left. So that would be at y equals, nope, x equals 6.5. So I need all the points on the parabola to be equidistant from the focus to the vertex, and from the focus to the vertex and the directrix to our parabola or whatever it is. So a point on the parabola is equidistant from the focus and the directrix. So the easy way to kind of figure this out, and easy in quotes, right, is to go twice the p-value to the other sides. Like for this one will be up and down of our focus. So p is 1/2, so I'm going to go 2p above, so I go 1 unit up, and 2p below, 1 unit down to graph those. So I'll write what these points would be. This guy would be 7.52, and this guy would be 7.54, would be 2 points on the parabola. You could also get points on the parabola by just subbing numbers into the equation, things like that. So that's another example of putting a parabola in standard form and graphing. You guys can try out the rest.